The Design Your Own Game Controller workshop aims to merge creative physical production with technological fluency. Central to this workshop are the Arduino Leonardo and a selection of central sensors, which lay the groundwork for exploring the construction of an engaging controller, one that can be used to control digital avatars. This documentary film delves into the intricacies of the design and build phases, exploring the challenges and triumphs encountered by our group members. Our game controller concept drew inspiration from Dave DeDuca's I Have These Two Faces, and the intuitive kinesthetic engagement seen in Nell Mendoza's Disruptive Devices. DeDuca's work infuses our design with a commitment to create fun and memorable experiences. It encourages users to immerse themselves in a world where interaction becomes delightful discovery. From Mendoza's creation, we embrace the seamless melding of human motion with digital response, ensuring our controller is an intuitive extension of the player. We also honor the meticulous craftsmanship and physical narrative seen in traditional Chinese puppetry. This ancient art form teaches us the value of tactile interaction, reminding us that play is not just a visual journey, but also a tactile adventure. This controller is crafted to transform the simple, tactile sensation of pulling strings into a dynamic digital experience. Each string, when pulled, controls a virtual arm on the screen, mimicking the extension and retraction of the limbs. The pulling of the string becomes a gesture of command, a subtle dance between the physical and the virtual. When the strings are pulled to their limit, indicating that the arms are fully extended, the LEDs and the vibration motors reach their peak. This feature serves a dual purpose. It provides a clear sensory signal to the player that the maximum extension has been reached. It also helps protect the physical structure of the controller by discouraging excessive force. Additionally, we include a humorous audio element. As the strings are being pulled, a human voice emits a comical scream, implying the virtual character's discomfort with being stretched. This audio addition was not intended to be distressing, but rather to add a layer of lightheartedness to the interaction, offering a quirky, audible feedback that reflects the character's reaction to the player's action. At the heart of the system lies a rotating arm piece, which is connected to the potentiometer at its pivot point. The outer end of the arm is tethered to the string, which, when pulled, courses through the pulley system, inducing a rotation in the arm and consequently the potentiometer. This mechanism effectively captures the essence of pulling action, converting it into a form that the potentiometer can interpret as the change in resistance and ultimately translate that into a digital input. During production, we employ laser cutting techniques, utilizing 6mm wood for the steady base and frame, and 5mm acrylic for its clear, intricate components. We encountered some challenges in ensuring a fluid interaction between physical controller and the virtual avatar. Calibrating the potentiometers to accurately measure string pull distances was crucial, as was mapping these measurements to the avatar's movements. We also integrated vibration motors and LEDs to provide tangible feedback, finally tuning their intensity through the Arduino's analog output. Additionally, in our Blender and Unity workflow, we rigged a downloaded ARM model and imported it into Unity. Writing C# scripts was pivotal in converting potentiometer string data into numerical values, enabling responsive ARM animations. However, timing discrepancies between Arduino and Unity signals initially delayed avatar response. Adjusting the Arduino delay settings proved essential in synchronizing physical action with the digital reactions, significantly enhancing user interactivity and ensuring the avatar accurately mirrored the user's movements. In conclusion, we acknowledge its potential as unique exploration of physical-digital integration. While the concept of using strings to control a digital avatar proved innovative, we recognize that the accuracy of this method, particularly in representing directional pulls, requires further refinement and testing. This project has been a valuable learning experience, particularly in understanding the complexities and possibilities of merging the physical with the digital.